Hello, I'm Andrew Annex. Just to reiterate, I'm a fourth-year graduate student at the Johns Hopkins Department of Earth and Planetary Sciences. And I'll go into the history again a bit later, but I started developing SpiceyPy, which is a Pythonic wrapper for Spice in 2014 when I was still an undergraduate, but I was doing work as a research assistant with Cassini imagery at that time. And let's get started. So what is spice? Spice is a drug produced, seems on arachis. It's related to sandworms and allows you to, extend your life and navigate the universe. Actually, that's just the joke I wanted to make. I mean, so what is really spice? Besides a reference to Dune, spice is a very real tool that's developed by the NAIF facility at JPL, and it's a collection of software API, a collection of tools and documentation to do all sorts of things in terms of planning planetary orbit, planetary missions, in terms of seeing the ephemeris information, which is the positions of planets and moons and spacecraft through space and time. So if you want to know where my spacecraft is at what time, well, the chances are it's loaded in a SPICE file, and engineers and scientists are using SPICE to get at that information. There's a pretty extensive, this slide is, that's sort of in the picture there, stolen from the NAIF, and they have a fantastic website, and I'll post a link at there's a links like posted throughout this presentation, and we'll show it again at the end. But it's been in development for decades now, and it is an open source project, so all the source code is navigable and everything. And this is the slide for, why would you even want to use SPICE? There's just some examples for the sort of scenarios that it's sort of envisioned for, and a lot of that ends up being like sort of observation planning. When will my spacecraft be within this elevation range to take a picture of this area of the surface? And what are the lighting conditions at the time? It's like all these things are constrained by the geometry, the positions of the planets, the geometry, orientation of the spacecraft, and where the sun is in relation to all that. So it's used extensively throughout planetary science. It's practically foundational. At the same time, it's a lot of the time it's obfuscated. You can go a whole career not directly using SPICE yourself, but something you're looking at, some data you're interacting with, some other paper you read, it used SPICE at some level. And for everything. So I work on Mars now. I use HiRISE to do observations, but even though I'm not using SPICE by hand day to day for that work, it's still relying on SPICE underneath to map project images. So this is a animation that should be playing. That's not great. It says unable to play. Okay, well, imagine things moving around in that little screen. It's just an animation of solar orbiter sort of going around with Earth and Venus. Circling back, what is SpiceyPy? SpiceyPy, again, I've sort of stated it before, is a Python wrapper for SPICE. It's community developed, it's open sourced, and it's on GitHub. And the way it works is it provides an interface to the C-SPICE library. So SPICE is originally developed in Fortran and it's sort of translated to C. There's a C library that is then wrapped to be interfaced into MATLAB and IDL via the IC and MICE toolkits that the NAIF provides. SpiceyPy is that same idea. It's a Python version of the same to interact with the underlying C API underneath. And it can be installed with pip and conda forge, so it's super easy to install. It's open source, I said before. It's a specifically MIT license, so it's a pretty permissive license. It's fully tested. A lot of the tests are lifted from the actual SPICE documentation. So I'm getting a chat. Oh, okay. Sorry, I'll stop paying attention to that. Yeah, so a lot of the tests are themselves pulled from the NAIF documentation for those functions and serve as working examples for you to get started. And when we say tested, what does that really mean? That means that the function is tested, it's executed for every change to the code base. Those values it returns are then validated against some known output. So I'm able to make quick development on it and able to see quickly if I make a change, if it breaks anything, for example. So that's one of the huge advantages for having a fully tested code base, and we're at 99% or slightly above that. It's pretty immaterial what's left. And the documentation is automatically built from the source code, and we can talk more about that later, and it's posted on Read the Docs, which is a free service that hosts documentations and searchable, and you can download a PDF if you want. So yeah. So over the years, I've gotten a lot of questions about, oh, why doesn't SpiceyPy do this or do that? And I'm next few slides to start talking about what Spice is and isn't, and sort of the philosophy. SpiceyPy provides the Spice API in a Pythonic sense, so there's some simplification, but it's not a rethink of how Spice should work. It's not a change to an object-oriented interface, for example. I needed to define a scope for the project, and the minimum goal is to be able to use all of Spice in Python. And that's what SpiceyPy is able to accomplish by keeping to a sort of narrowly defined scope. And also SpiceyPy does not manage kernels for you, which is its own sort of unsolved problem in the planetary and for Spice users, and the topic of discussion. And it does not install the tools for users because, again, I'm only interested in providing an interface to the API. Things beyond the API, tools that are included with the Spice toolkit itself, because, again, it's a collection of tools, and the API is sort of outside the scope of what SpiceyPy is supposed to be. And the docs, while I have them, and they're automatically built from the doc streams for the functions, they're not supposed to replace the NAIF documentations because there's simply a lot of it, and I'm not funded to do this work. And also I want to defer to as much as possible as the expertise from the NAIF. They know what they're doing for sure. So now I'll talk about, again, a bit more about the history of SpiceyPy. So it started in 2014 as a complete rewrite of Spice, and then I quickly realized that was completely insane. So I switched to this sort of wrapper once I figured out how to get that part working. I meant to say this a couple slides ago, but it wraps the C library by using a built-in function in Python, built-in module in Python in the standard library called C types. And NumPy actually also uses that pretty extensively. So it's something every Python distribution is going to have, like Python C, excluding PyPy for the moment. I can't see full of my graph because of the lovely pictures of everyone on the side here. Oh, there we go. And you can sort of see through time, the releases of SpiceyPy, various versions, are these great vertical bars. And I've seen pretty linear growth, which is, I mean, great for this library. So we're at like 150 stars or so on GitHub, and maybe 50 or so forks. And that's sort of just an indication of broad interest by people in general. I think now that I've gone over this section, but so I'll just say this picture on the right, we're actually looking at the source code for just one of the wrapper functions for SpiceyPy, and it's specifically wrapping the function pxform. And you can sort of see the sort of how the internals of this works. I'm taking some parameters and I'm casting them to Python objects that are compatible with C types. I'm passing it in to actually the call to Spice with a libspice call. And then I'm converting that input back into something that's recognizable to a Python user, to a NumPy array. And what's great about writing it all in Python as opposed to compiling something in Python and such is that it's all pure Python. I don't have to compile things. It's easy to edit and cross-platform naturally without needing to recompile anything other than the underlying C library. So how do I use SpiceyPy? This is just a whatever, but it's really easy to install. It's just a pip install or a conda install if you're a conda user. And then you import it. And now I'm going to show something kind of cool you can do. Let's go escape from that. So I'll post this as a code example later, but I sort of resurrected this notebook where I'm plotting the position of the Mars Science Lab over like a 4-year period through time. And I think I've been talking slowly, so I will skip through some of this code now, but just show the outputted map here that everyone should be seeing. Hopefully my internet connection is keeping up to this, but in any case, this is Gale Crater on Mars. And the positions, the line dots here from this line are the positions of the rover in longitude and latitude recovered from the SPICE data that the PDS publishes for the Mars Science Lab rover. The background images and such are from the USGS and the USGS Astrogeology Center, so they're not like perfectly registered, but I believe if we zoom in here, you can get a feel for what we're able to sort of do with SPICE. So we're getting a geometry information from the mission over a 4-year period and plotting some map. That being said, I'm sure people who are very familiar with MSL will notice this is not quite right. There's a registration issue with this sort of high-rise mosaic in the background, so don't worry about that too much. It's not something I can correct for in this sort of quick demo. All right, back to the presentation. That's really disappointing. I'll post a link to this when we have the chat in discussion. So I was going to play a video from the American Natural History Museum. They have a new show that now I guess no one's traveling to go see, but they use SpiceyPy to do these fantastic animations of like Rosetta taking pictures of a comet to all the orbits of the planets. And it was really cool to see that SpiceyPy is being used for sort of an educational outreach and non-scientific thing. That being said, SpiceyPy is being used by like active spacecraft missions by various scientists and engineers at NASA centers and universities, as well as like new space companies. I've seen some users from that domain, and then just regular software developers trying to do something cool for a side project. So for users people who haven't used SpiceyPy before, here are some great links and how to get started with SPICE in general. So I'll just leave that up for a second, and I'm sure you'll be able to refer to them in the past, but mainly the NAIF provides a fantastic set of documentations and tutorials for how to use SPICE, and also Open Planetary has a series of SPICE tutorials as well. In this part of the talk, I'm just going to give a general status update. So there, from the prior slide where we're sort of showing the releases, there was kind of a flurry of activity sort of late 2019 and early 2020, where I was preparing things for a Python 3.0, a SpiceyPy 3.0 release, because I was coinciding with the deprecation of legacy Python 2.7, and those versions, like, they're now gone as far as I'm concerned. So I maintained compatibility with those for a while, but dropping those I think is good, because I haven't used Python 2.7 since 2014, for example. That allowed for some simplifications and changes to the doc strings, which we can talk about sort of once I'm finished with these slides. And there were some minor additions, such as like a bug fix for daft GDA, thanks Jesse, and some of these like sort of hidden functions that are in the Fortran SPICE API, but are not necessarily exposed to the user in like a user-friendly way in the C SPICE API. So again, SPICE is developed in Fortran, so it has like hundreds and hundreds of functions. C SPICE wraps like a subset, a large subset, but a subset of those. And there's just a few of these functions that are really useful from the Fortran SPICE library that I'm able to include, because they are all translated into C automatically to build C SPICE. They're just not exposed in a documented friendly user way. So that sort of makes SpiceyPy more useful. And if you look at sort of the comparisons of the number of functions that SpiceyPy has implemented versus IC and mice, which are the NAIF provided IDL and MATLAB wrappers for SPICE, there's a lot more functionality preserved in SpiceyPy in comparison. Another cool thing that happened, this is also part of the push for the next release, was I submitted SpiceyPy to the Journal of Open Source Software, JOSS, and it went under peer review. This is just a screenshot of their page. I have a new DOI for SpiceyPy, which anyone who's using this for anything, please, that involves a publication, let's put it that way, it's something that can be tracked. Please cite SpiceyPy using the DOI in your papers and in your conference presentations and such. That'll be a huge help to me to sort of show and illustrate how widely SpiceyPy is being used. And I also have a link there to the review, which is all in the open. The review went really well. It went really quickly. There were some suggestions for documentation improvements, which I'm always welcome to, but there were no major issues revealed by the review, so that was great. So to sort of wrap up, I think this is my last slide. If not, I have like a short one next. What's next for SpiceyPy? I'm sort of due to make a new release probably in May, maybe late April at this point, which encapsulates like some of the documentation improvements that I personally want to make, and then some user requests that have happened. And then there's sort of two other sort of larger term projects that I think probably would happen by the end of the year unless someone else wants to take them on, where I really want to improve the error system in Python, SpiceyPy, sorry, to be a bit more parsable using custom defined errors in Python, because Spice has a ton of defined errors for specific situations, and SpiceyPy could do a better job about allowing users to do try catches with those different types instead of parsing things. And then maybe there's going to be a new release of CSpice at the end of the year. That would be version N67. So when that happens, SpiceyPy will probably see some changes to include those new functions and to work with it compatibly. And then there's sort of this thing that's still in the air about Google Summer of Code, and there's sort of a ESA equivalent. Maybe there's some students that will be interested in contributing to SpiceyPy, and I'm working with a group in California that's sort of interested in taking the lead on organizing that, but we'll see. Okay, so here's my conclusion slide. So in short, SpiceyPy is tested, stable, and ready for you to use. Here's some links to the documentations, the citation for JOS if you're using this in your research and publications, and some of the other sort of to-dos that I'm sort of looking at for the next few months to year, improving those errors, that error system, improvements of the documentation. I'm always thankful and happy to work with people interested in improving just a small area of SpiceyPy. And I think it's a super great thing for people to want to do. So I'm happy to work with you on that. And also maybe trying to make a logo for SpiceyPy. It would be cool to make some t-shirts. And I think I'm basically at my time. So I will stop sharing my screen for a moment.
Thank you. Does anyone have any questions?
Michael here. I was wondering if you already have a general wrapper around the spice errors, right? And if you catch and parse them, then is it not possible to write basically an intelligent wrapper that basically spits out exactly what the spice error is?
Yeah, and that's essentially what would happen, I think, in this thing. It would be sort of, I mean, ideally that would be included in SpiceyPy as opposed to someone writing it just for themselves. I think that, in particular, the inspiration from this came from the PDS rings node, which for a time had their own Python spice wrapper, which worked in similar ways to SpiceyPy, but did not use C types. I'm forgetting exactly. I think they compiled against the C library of Python, actually, which is sort of the more traditional way of integrating C code with Python. But in any case, I think it was Robert French had a pretty neat bit of code that I have in a branch, I believe, on the SpiceyPy repository, where depending on what was in the error message, it would actually cast to the Python, like a SpiceyPy memory error, for example.
Hi, Andrew.
Oh, hey, there you are. So yeah, no, it was really cool code,
Yeah.
and I thought it was a great. It was a really cool thing to think about. The problem is it might cause a breaking change in terms of the API. People install that new version. These errors might not work with pre-existing code. So I had to. I didn't completely think it through, but I think if basically there's a top class that's the SpiceyPy error or whatever it's called right now in the code base, then it should work. But I don't think I solved all those issues. I just sort of like gave it an hour and then walked away for a couple of months at this point.
So Andrew, just to be precise, we do still have that Spice interface available. It is still what we use in-house. We've tuned it very carefully to be very high speed for vector operations, and that's the main reason we've continued to use it. But we do not have a Python 3 version of it, which is becoming a problem.
Okay.
So how much do you actually vectorize your work? If I pass in arrays, does it use the vector versions of all the Spice functions?
Not always, not uniformly. And that's something that I think could maybe be done better by defining a decorator in SpiceyPy. Right now, it's sort of done on a per function basis. And if you actually look at the source code, it's not like, not all the functions have it. It's like one that does is SPK-POS, for example. And I do this sort of careful unwrapping thing where I check if the I think it's like the LT array, the time like input array, if that's an iterable, then go down this other code path. And then I do some sort of clever things where like if I'm returning a double value from that Spice function, I instantiate it once, and then for each iteration, grab the value, and then I don't like create a new C type C double, which this is very jargony, but that saves like a considerable amount of time as opposed to just a naive for loop.
Right. Okay. Yeah. I think that seems to be the biggest difference right now. I would love to be able to switch over to yours, but we have our own C library that we wrote, and in the C library, we play with the Python types and the memory mapping to do the vectorizations, and we do that for all functions. And the code that we run runs millions of data points for a million observations, and so performance is extremely important to us.
Yeah. Yeah, and I think it would always be faster doing it that way, pretty much. I mean, there might be some tricks one can pull in Python, but I think it would have to use some sort of. There are like libraries like Numba out there and such that have like JITs, and the question is, can you interface to a C types? Like you kind of have to go in between the Python interpreter, that's the word I'm looking for. So yeah, sorry, that's like a tangent. I think SpiceyPy does it in a reasonable way. I don't know, I doubt it's as performant as your solution.
So the Number supports jitting C types, so I think in principle it should be possible.
Oh, fantastic. Yeah, I'll take a look at
so
that.
That could be a hackathon project.
Yeah, no, that'd be great. And there's some other considerations, like sometimes it's not entirely clear on the context of a Spice function, like, and they have inconsistent sort of handling of this, even in, I think in the like IC interface, where you can have multiple values. You could think like, should it just be iterable on the times array, or do you want to look at different like targets at the same, like it should really. And then how do you like square that? Like probably the most naive thing is like you'd only be interested in one target at a time, and then a whole bunch of those times, for example. But it depends what the user really wants at that stage, and I can't anticipate all those use cases. So, anyways.